Welcome to tutorial on Unit 2, the second law of thermodynamics. Tutorial question 1. An inventor claims to have developed a power cycle capable of delivering a net work output of 410 kJ for an energy input by heat transfer of 1000 kJ. The system undergoing the cycle receives the heat transfer from hot gases at a temperature of 500 Kelvin and discharges energy by heat transfer to the atmosphere at 300 Kelvin. Evaluate this claim. Now, the question is asking us to verify a claim that an inventor has made. The inventor is saying that he's developed a system that can take in 1000 kilojoules of heat and give a work output of 410, but the system is operating between a heat sink of 300 and a heat source of 500. And so with this information, we are going to verify whether it is possible to have such a system. Now let's look at the diagram. Now the diagram has put all the information together. Now at the heat source, we have a temperature of 500 degrees Kelvin, 500 Kelvin, and then the heat input as 1000. Now we can only verify by finding out whether the actual efficiency is less than the maximum efficiency, because once we know the operating temperatures, we can calculate the maximum efficiency of the system, and then we'll cross-check that with the actual efficiency. If it's fall within the range, then it's true, otherwise it's not true. Now let's make this assumption. We are assuming that the hot gases and the atmosphere will play the role of the hot and cold reservoir, and so we'll first of all calculate the actual efficiency claimed by the inventor. Now let's insert the values into the formula. Efficiency equals work output over input heat. Now if you do that, the efficiency is going to be 410 over 1000, 410 being the work output and 1000 being the energy input or the heat input. That gives us an efficiency of 41%. Now let's go on to evaluate the maximum thermal efficiency. Since any power cycle operating within a particular reservoir, operating temperature can have some limit to its efficiency, and so we'll calculate the maximum efficiency and then compare with the actual efficiency. Now if you use the formula 1 minus Tc over Th, it gives us 1 minus 300 Kelvin over 500 Kelvin, and that would result in 40%. Now what this means is that with the operating temperatures, the maximum efficiency that can be achieved is 40%. Therefore it is impossible for any system operating within these conditions to have an efficiency more than 40. And so we conclude that since the thermal efficiency of the actual cycle exceeds the maximum theoretical value, the claim cannot be valid. It is not true.